first of all, thank you so much, Konstantinos, for being a guest speaker for the session of PyData Tunisia. I'm very happy to have you, actually, because you are, at the best of my knowledge, for now, the first AWS machine learning hero to hold a session in Tunisia. So that's something that we are looking forward to seeing, to have better and better speakers each session. And for those who don't know, AWS Machine Learning Hero is the AWS or Amazon Web Service equivalent to the Google Developer Experts program. So I'm the Google expert, he's a AWS Machine Learning Hero, but in the end, we all are community actors that try to help the communities. So Konstantinos is one of them, and hopefully we will have more guest speakers of the same caliber. So Konstantinos is also the head of data engineering at Orpheum. He will talk about what Orpheum is and does later in the session. And today we're going to talk about serverless machine learning with AWS. So all of us, let's say most of us, are already familiar with the traditional, traditional deployment of machine learning apps using normal, let's say, servers. But then sometimes we don't need to run 24/7 services, or we don't need a hardware specific to that. We might need just a little bit of code that just does the prediction, that's it. And that's where serverless architecture and backend comes in handy. And hopefully we'll see how to use that for machine learning today with Konstantinos. So 5 minutes to give you a better idea on what PyData is and what you do. Just let me accept this to not forget, and go. So PyData basically is an international community of 186 now groups of Python and data science enthusiasts all over the globe. And for some reason, in their GPS, Tunisia is somewhere in the sea. We don't have land, but hey, that's just a detail. And they have been going at it for years now, focusing on Python, on data science, on data analysis, on linear algebra, and everything that is between the two. So they combine everything with Python and data and whatever comes out of it. So you can check their content on the official PyData YouTube channel to see what else they do. But basically, the focus of PyData is hosting sessions like this one, and should have been offline, but you know, the reality of things with Corona. But there's also a lot of content online. So as I said, you can check the YouTube PyData channel and see what type of content will be there, is there, and hopefully this content and the other sessions will also be uploaded there. So that's for PyData as a whole. Now, PyData Tunisia, I'm really excited to say that we almost reached 350 members, and this is only on 4 sessions without any sponsored ads. So thank you so much for our community to always be with her. I'm already seeing names in the Google Meet that are always in the session, so thank you so much for that. And we hope to be able to scale this up and get better and better content, better and better speakers for the upcoming sessions. So for those who are curious, we host sessions once a month so that we don't get into the stress of quantity. So we want to stay at the quality side. We always want to present high-level content and advanced content, so to change. So for now, because we don't have a lot of manpower, we only do this once a month. But if we have people that are interested to help us host better sessions or outreach to more people, we are glad to have you with us. So please reach out to me. All right, so that's for PyData. I'm not going to take any more of your time. We are going to now go directly with Konstantinos and see what he has for us in our plate. So, hey, Konstantinos.
Thank you very much for the nice introduction. I'm really happy to be here. Let me start sharing my screen. Let's stop procrastinating. Can you see my screen?
Yes, and just before you start, because we have 5 more members, I just want to repeat and say that everything is recorded. It's not sure that you will find the recording afterwards, so it's not permission to leave. And if you have any question, just raise a hand or put it in the comments, the chat, and I will relay the message to Konstantinos. Thank you.
Perfect. So hello everyone. I'm Konstantinos, and today we're going to see how we can deploy our machine learning models on serverless API and especially specifically on AWS. Firstly, I want to say a few things of who am I. I'm in the business for around 6 years, a little bit more. And the past 3.5 to 4 years, I work at Orpheum as the head of data engineering. I'm also a data scientist by practice, and I have my master's degree in data science, but I don't practice it in Orpheum. On the AWS part, I recently, I think it's almost a year now, I became an AWS machine learning hero, and I am also the organizer of the AWS user group in Greece. I maintain a blog, thelastdev.com, where I mostly write about machine learning stuff, data engineering stuff, and it's more AWS oriented. But I haven't written anything the past 7 months because I recently became a dad and I have no time at all.
Congrats.
Thank you. You can also find me in socials, Twitter and LinkedIn. You can ask me whatever you want, considering AWS, data engineering, and sometimes I answer the personal questions. So, what is Orpheum? What do I do on Orpheum and what Orpheum does in general? We are building a digital infrastructure for the music industry. And pretty much we're trying to cover all the end-to-end journey of an entity, of an artist, publisher, record label, and so on. So that end-to-end journey is actually when we get the media from the artist or the publisher. We onboard the rights data, who has ownership to what, and what is the percentage, and how we can funnel the revenue stream. We execute the agreement, or we implement the agreement that it has, and from there we start generating and collecting revenue for that entity. We have ways of generating revenue, and we have ways to attribute the proper revenue to the proper entity. After that, we generate payment reports to the proper content owner, and we also provide some business intelligence, insights, and analytics on the actual tracks that they have. So, in a nutshell, this is Orpheum, and we are handling lots of data. We have a data team, which is currently 26 people in the data team. In next week, we're going to be 28. And we're split into 3 major groups, which is the data science, where they create machine learning models, they do the analysis part, and they deploy the models to APIs. I am in the data engineering team, which is mostly big data stuff, Snowflake, AWS, Spark, and so on. And there's the business intelligence team, where mostly the analysts and the business intelligence guys to create dashboards for our clients and internal also. So, enough of these things. Let's go into the gist. I want to start by describing a machine learning flow, a typical machine learning flow, where you have a problem and you're trying to solve it with machine learning. Let's say we want to create deep learning model to actually machine learning model to categorize the iris flowers. So the first thing you do is to search for data to train your model. After you have a reasonable sized data set, you want to clean and format your data to, first of all, to perform exploratory analysis, but you have to prepare and transform the data in order to be able to fit your model. So after you have your data, you create your model, you train it, and you evaluate it. You make sure that your model is not overfitted, you have a proper accuracy, you make sure that your model solves part, if not all, the part of your problems. And when you're satisfied, you're integrated with production, you deploy it. By deploying, you can create an API, you can create a package, You can throw the model as a binary to the face of a developer, whatever you like. But the job does not end there. We have to constantly monitor the model. We have to debug it. There's errors, and in a day, maybe a month, maybe a year, the model is going to need retraining because the model is going to see new data that is not going to recognize, will fail to make an accurate prediction, and then you have to fetch the new data, you have to clean them, format them, and so on, and go over and over that endless loop. I've never heard of anyone of creating the perfect model that will not need retraining in the whole millennia from now. But yeah, this is typical machine learning flow. And in this presentation, we're going to focus on the blue part, on how we integrate the model into production and how we monitor and debug that model. So what we will learn today? We will learn what is serverless. We will learn what AWS offers on its machine learning stack. We'll learn how to build the serverless API using the serverless application model, which is an open source tool of AWS. And then we'll learn how we can deploy that model to the serverless API we created. So first things first, what is serverless? For those who do not know that keyword, that phrase, serverless computing is a cloud execution model where the cloud provider allocates resources for you on demand, and it takes care all the servers on behalf of you. This is actually the definition in Wikipedia. So serverless means that we have no servers to manage. It scales with usage because the cloud provider, scales it on demand. You never pay for idle, and you never pay for what you do not use. And by design, it's available in fault tolerance. It's built that way. So the AWS offers large serverless stack. This is just a few of the services. We can see the AWS Lambda, which we're going to see in the demo, which is similar to GCP functions or serverless functions. You have a queuing system, serverless queuing system. You have NoSQL, serverless NoSQL. You have Amazon Athena is pretty much like BigQuery, but BigQuery is a data warehouse. Amazon Athena is more like Presto, serverless Presto. We have Amazon CloudWatch. We're also going to see that in our demo, where it's a serverless way of monitoring your logs on Lambdas, API gateways, wherever you want. And we're also going to see the Amazon API gateway, which is a means of Amazon to provide you a URL that will trigger several services in AWS. So you do not need to set up, let's say, an Nginx server and then assign a URL on it to use it. And lastly, on the serverless part, we have AWS SAM, the Serverless Application Model. As I said before, it's an open source framework for building serverless applications, and it has a single deployment configuration. It has local testing and debugging. This is amazing. Imagine that you do not have any notion of where this is going to be deployed or how is this going to be deployed and called back and so on, but you have a way of setting it up locally and test it. It has built-in best practices. It integrates well with development tools, with Python, with VS Code, and so on, and is built on top of AWS CloudFormation, which is a service of AWS where you define in a YAML format the resources you want to use, and it creates those resources. It's pretty much infrastructure as code, but infrastructure as YAML. Now for the machine learning part in AWS, it is divided into three major categories. We have the AI services, we have the ML services, and we have the ML frameworks and infrastructure. The AI services, it's a bunch of machine learning and deep learning models already deployed, and they have an API, which you can call and use that trained model. In some of the services, you can train your own models, not your own models. You can train the model with your own data, but the model is there. For example, the Amazon recognition, which I used a lot, there's an API where you can send an image, and it will return you with the objects with the image, or it will return the emotions the person have on the image, and so on. You have Amazon forecast, you fill it with a time series, forecast a time series, so on. A level deeper, there are the ML services, where on the AI services, you do not have to know machine learning, you do not have to know deep learning. You just hit an API and get a response. On the ML services, it gets more hands-on. You can build your own models, you can train them, already building models in AWS, and you can use the whole ecosystem to create your ML pipeline, your ML flow I described earlier. And the start here is the Amazon SageMaker, which literally I haven't seen similar service anywhere in the cloud. And it's a start of the AWS machine learning stack. With SageMaker, you can download the data, pre-process the data, train your model, create your own model if you want, and literally with one line of code, deploy it into an endpoint. This is not serverless. I think they are going to release a serverless version, but this is not serverless yet. But the beautiful part here is that you do not have to use all the tools in SageMaker to create what you want. If you want just to train your model, you bring your own model, you use the SageMaker resources to train it, and then you get your model and you walk away. You don't have to pre-process the data on SageMaker if you do not want to. So you can pick and choose whatever service that SageMaker provides and use that only. And ML frameworks infrastructure is the core level where all the frameworks are actually sitting. Amazon SageMaker use the infrastructure and the framework, so you can use whatever you like on SageMaker, considering the deep learning frameworks and machine learning frameworks. And also there is a really nice feature, a new feature, new in quotes, this is a screenshot from 2018, the inferencia part, where you can train your models on CPUs specifically designed to run neural networks. So you lose a bit of performance when it comes to training and predicting, but you cut half the cost, at least half the cost. So it's really, really nice for someone who is starting as a company on the deep learning stack. So yeah, SageMaker is an end-to-end machine learning platform. It needs literally zero setup, just a click of a button and you have a Jupyter Lab ready to try, whatever you like. It's flexible on the models, as I said before. It supports most of the most popular ones and some outsiders. And you pay by the second. This is very crucial. When you train a model, you do not pay for setting up the environment, installing the dependencies, spinning up the instance, and then closing down. You get built by your training seconds. And then there are other workarounds you can do to cut the costs even more. So, enough for the theoretical part and the phrases and the explanations and so on. Let's see what our goals are for this presentation. As I said before, we want to deploy a machine learning model on the serverless API. So we want to get a model. I have already prepared that. I have created an XGBoost model to predict the iris flowers. We want to create an API, but we want to be scalable because we do not know the traffic. We can have one user per month, or we can have 1 million users per hour. We want to be scalable, but we do not donate a kidney or something to support that infrastructure. And we want to deploy that API with our model. So first thing that you have to do is to create the architecture. And the things that I mentioned above, when you go the traditional way, you certainly need a VM machine to run your endpoints. You probably need the load balancer in front of it, in case you need another machine to spin up because your first machine is loading up. For fault tolerance and so on. You need an autoscaler. When you have, let's say, 70% of CPU usage on your machine, you want to spin up another 2 machines to handle the load, and the load balancer will handle that. And I think you'll need something like Stardog or New Relic or something similar to monitor your the performance or your machines and your models performance. So I just mentioned 5, 6, 7 services that you have to do. Also, you have to create the API using Flask or Django or Fast API. You have to route it, add certificates, and so on. But with serverless, it's that simple. You just have your API gateway. It's provided by AWS. It provides you a URL. You can also host it on top of another of your domain or some domain. We want a path. We want to use /predict to invoke the API. We want the code of the API. That's a few lines of code to load the model and predict. And we're also going to use Docker images on that because we have a model. We have XGBoost dependency, which is almost half gigabyte. So I want to create an image which will easily spin up. So let's do the demo. In the demo, we're going to see code example. We're going to see the AWS console, and we will have a small walkthrough. And also, we're going to stress test the API to prove you that it's actually stable. Do we have any questions so far? So went really fast.
So if anyone has any question about the AWS stack, the architecture, the stress test, or demo time, just write a small message in the chat, or feel free to just open your mic and ask a question. Let's just wait like 10 seconds for if anyone is typing a question.
Yeah, sure.
Let's see. Right. So I think one question would be, one simple question would be for the model. So for the model that can you use any model, any type of model, and as long as there are dependencies, and just put it in the Docker image, or is there any like limitations that you have to follow?
Obviously, the example that I'm going to run is not using deep learning. So if you have a very heavy deep learning model, the Lambda is going to struggle. But you can compile the deep learning model. I think TensorFlow, Gluon, MXNet, PyTorch, and maybe Kafka, I'm not sure. You are able to compile your model, your deep learning model, to run on inferentia. So you can use a Lambda function that runs on inferentia to predict with your deep learning model. When it comes to which framework you're going to use, which model you're going to use, and so on, there's no limitation. You can do whatever you want. But when it comes to deep learning, it's very heavy. There are options. I've seen BERT running on Lambda, so yeah.
Thank you. So it seems that no one has any question for now. They're good at this point, so we can continue.
So here I have all the serverless API, and we're going to run those 5 commands to initialize everything, build our model, build our serverless API, test it locally, create a repository on AWS in order to push our Docker image, and then deploy the model, the serverless API. I have already created the model in a pickled version, but obviously you can get that model whatever you like.
So can you run us are you going to run us through the architecture of the folder, or are you going to make a new folder?
Yes, I'm going to run you first through the architecture of the folder, say a few things about it, and then we're going to build it together using the 5 commands. So in a very few words, we have one file, which is the Lambda handler, which is the function that we want to run. Let's ignore for now the authentication. The authentication, I added it because I had the API up and running for the past 7 days, and I didn't want to pay $1 million AWS because someone can find it and destroy it. But yeah, this is the lines of code that I added. Let's remove the print also. It's useless. So I load the model. I load the data from the request body. I format my data, predict it with my model, and return the results. That's it. Okay. This is the first file. The second file is the Docker image, obviously. The Docker file. I install my requirements. I copy my requirements, install them. I copy the 2 files that I need. Let's forget about the authorizer. I copy the model. Here you can use, let's say, the AWS S3 copy command and get the model from S3 each time you build your Docker image. That way you have always the latest version of your model. And this is a command that is pretty standard, and you'll see what I mean in a few. I have my requirements.txt with all the potential things that we're going to need. With this demo, I just need those 2, both 3 and XGBoost, but I added a couple to see the code start in a while. And last but not least, I want to define how I'm going to deploy everything. And this is what I called about SAM and CloudFormation. Very, very quick. We have the API, we have the function, we have on how we're going to invoke the function, and where is the image. That's it. So let's try and create it from scratch. So if I go here and say, let's create a directory, and can you see my screen, or is it too small?
In my case, I can see, right? Can anyone see the code? Because he is going to show us how it works. Can anyone see, everyone see the code? Just type yes or no in the chat, please.
It's not.
All right, very good.
Okay, perfect. So first thing that I'm going to run is some init, which is the way to initialize my serverless thing that I'm going to start to write. SAM does not support only serverless APIs. It has all the serverless services inside. So I get a wizard where I'm going to choose the quick startup, the start templates. They have a boilerplate. I'm going to select the image part because I want to have a Docker image. You can also avoid the Docker image and create a Lambda specifically from code and deploy elsewhere your dependencies. But the image is an easier part. It asks me on what runtime, what environment I want to run my code. I'll select the Python 3.7. This is the 5th option, and move that thing over there. And the project name. Let's leave it sum up. Okay. And this is pretty much it. If I go here on the sum up folder, you'll see a folder called Hello World. It has the app as we saw it. It has the Docker file, pretty much as I have created my Docker file. And it also generated the template.yaml, where it has only the function. If you do not specify the API, it will create by itself. There's no dependency on that. It will not break or something. It will create the API by itself. It also comes with a really nice README where it actually walks you through all the steps that I'm describing right now on how you're going to create your first function, how you're going to test it locally, how you're going to create your local API and hit it with Postman or something, how you're going to deploy your API, and so on. So it's really, really nice documentation. So yeah, first thing, I'm going to go into my app file. Let's delete nothing. With confusion. See the partners there. Need it. Okay, so pretty much I copy the code that I probably have already run into my Jupyter notebook and import the code. Import NumPy, import XGBoost. I think we're okay. Let's
formatting.
Yeah. Let's return the results. Yeah, it's the flake code. It gets crazy. There. Perfect. Yeah, expect two black lines. There's your two black lines. Okay, that's it. If I now deploy, if I now run some deploy, it will create a serverless endpoint, serverless API, where when I hit the /hello with body that has data as a key, and there's a list of lists, you're going to have an API. I'm not going to deploy the API because it has XGBoost and my internet is crappy. So it will take around 30 minutes to upload the image to AWS. It will do it on once or each time I update my image, but the first time will be rough. So I have already created everything.
So basically, for the deployment product, all you need is run to the SAM init and then through the wizard, and then you have all the boilerplate ready for you. You just need to put the deployment, the prediction part, and that's it.
Yeah.
Nice. And then say you do the SAM deploy so that it creates something on the AWS console, and you have everything ready by then.
Yes.
Wow,
I would suggest to run those two commands, which actually, okay, the first command here is to log into the ECR, the Docker repository on AWS, and the second one is to create a repository on AWS. For example, here I have already created the PyData Tunisia demo, which is it was an empty repository, but once I hit deploy, it deployed the image, the Docker image into that repository. And the first time, also in the documentation, you're gonna need to say some deploy guided. So it will go you through a wizard where you manually enter the stack name, you enter the ACR here, for example, the result from there, where to push the image, and some other stuff. But once you do that once, it will create some config.toml, and each time you run some deploy, it will use that configuration. So you only need once to define some parameters for your stack. Once you do that, once you deploy everything, you can see here there are some outputs. The outputs is actually on CloudFormation. When you go to CloudFormation, you're gonna see those three outputs. You're gonna see the URL of your API because you do not know it beforehand. You're gonna see the ARN, the ID of your Lambda function, and you're also going to see the ID of the roles that give permission to your API to trigger the Lambda, to invoke the Lambda. So let's go to the AWS console here. When you first log in to AWS, you're going to land in the homepage for AWS. But we want to go to CloudFormation. This is our entry point. Everything is deployed on CloudFormation with SAM. So if you want to find something that you have deployed, you're going to go to CloudFormation. So here you can see this is the PyData Tunisia demo that I have deployed. And you have some basic info, have a description. These are the events. These are actually a live feed of what is created first and what is waiting what, and so on. These are the resources that we have created. We have created the Lambda function, as I said to you before. We have created the permissions, the AMROL. We have the REST API. The REST API obviously needs states and the deployment. I don't know. I think the GCP has also YAM roles. They have an identity access management, and as far as I remember, it's pretty much the same. You can assign access rights. These are policies, and you can attach the policies to roles that say the role basically say that this resource has access to this resource. So the REST API has access to the Lambda function where it can be triggered by it. So let's go and see the resource that we created. Let's go first on the API gateway. This is the API that we have created. We have the /predict on a post. Here it basically says that if you trigger that API with the post request, it will go through a Lambda proxy. It will trigger the Lambda, and it will gather the results of the Lambda and bring them back to the client. And these are the stages that we have created. Have the version 1 states. Here we can see we want to add throttling. Let's say I don't expect more than 100 requests per second. If I have 200 requests per second, it means that something has leaked, maybe an API key or a credential, some credentials, and we have to throttle it in order to avoid large amounts of pain. For the sake of this demo, let's do 10,000. So yeah, this is it. This is the API. If we go to the Lambda, if we had choose the zip part, the artifact part, we're going to see the code here. But since we have an image, this is actually the image that we're using. And here, for example, is the PyData Tunisia I created with my with a command I ran. And all these deployments here are actually automatically deployed from SAM. I didn't deploy any images to the ECR. Everything is managed by SAM.
So any changes, any code change, any model change, everything is logged there.
Yes, yes, exactly. So let's test our Lambda. Let's create a new event. I want to do an API AWS proxy. Say my test one. Okay, this is the body. Save and test it. And it takes some time. It took around, not around, 2.4 seconds. The duration of the Lambda was like very, very fast, a sub-second. And it actually threw me an error of 400 with an invalid API key because I didn't define my API key in the test parameters. But it took 2.4 seconds. This is why it took that so much. This is the cold start on the Lambda. When you first invoke Lambda, it will take some time. It will take around 2, 3, maybe 4 seconds. And that's why AWS has to get the image, spin up the instances that it needs to for the Lambdas to run and initiate the Lambda. But this is only happens once. Now, if I run it again, it took 81 milliseconds. Again, 30 milliseconds, 52, and so on. So I found the Lambda, and it responds sub-second. As far as I don't remember exactly, but I think it's like half an hour or 1 hour before the Lambda gets called again. So if you keep hitting the Lambda, it's always going to be warm. And also there is a configuration on the Lambda to keep it warm by force, without actually, running the while loop and hit it once every 30 minutes.
Does it take does it count 30 minutes from the second it first warmed up, or 30 minutes from the last request?
From the last request.
All right. So as you said, if I just keep getting requests once each 30 minutes, it will always be warm.
Yes. Yes.
And I will have only to pay for the small duration of the request.
Yes, but there is also a configuration that it keeps optimally the Lambda warm. You do not have to do that anymore.
More, right?
You used to do that, but yeah, you don't have to do that.
Yeah, but won't I have to pay more? Because
yes, yeah. You'll pay more to keep the Lambda warm. That's for sure. But you always have sub-second response time. When I say sub-second response time, obviously, if you have a while loop that never ends in your Lambda, you're never going to have sub-second response time. The thing that if the actual request is a sub-second, the process that you have in your Lambda, it will be sub-second. You will not have like 3 or 4, 5 seconds waiting for the Lambda to spin up. That's what I mean when I say sub-second.
And it's basically at a rate of 0.001 per second.
What do you mean?
The cost. So is it like I know it's $0.002 per request.
Yeah, it's something similar. We're gonna see the last.
Okay.
At the end of the session, we're gonna see the pricing.
All right.
And some pricing examples. So yeah, I have my Lambda. I can actually trigger it. I have Postman set it up. I have my API. I have my endpoint, post request. I already added my key. Here I have a body, and I can hit it, and I get results. And if I do see, this is the second flower, the first result. If I do 1, 2, 3, I think. No, I still have the second one to 5, maybe. Oh, yeah, I got the third. So yeah, I have a real model behind it. So yeah, so I'm keep hitting everything. And the API responds back. But how do I monitor my API? And this is where CloudWatch actually takes place. I have a nice monitoring dashboard here where I see implications, the duration that it took. For example, here you see that it took around 2.5 seconds. It's exact how much it took, the first test that we did, how many errors I had, and so on. And also we can jump into the AWS CloudWatch, which is a serverless logging mechanism of AWS. Go here and see. Oh, there's my API key. By the way, you can let me send the API, the endpoint. Start hitting it. We are here.
Oh yeah, we can try it right now and see how real.
Yeah, why not? It has to be a list of lists, and obviously I haven't written any error handling, so you're gonna get 500 error, and then we get the API key. I'm going to delete the API anyways after the session. Oh yeah, this is the key. You have to add the X API key in your headers, and then the key, you can try it. You can go nuts. Or I think I can send a curl request. I think this is way easier. So yeah, you can play with that. You'll see that it's going to respond. So yeah, logging. As you can see, I had some prints. Do that. You'll see that we have the print part, but date. This is correct. No, this is correct. The date is correct. But okay, if I have nice logging on my Lambda, it's fine. But what happens if someone get 403, for example, not authorized, or 500, or you do not, or it searches for an API path, an endpoint that doesn't exist? How do I catch those errors? And you can actually go to your state, to your API, and enable your logging. You can actually do that from the CloudFormation also. You don't have to do manually each time you deploy that. But let's enable everything. And can you spam a bit the API? I'm going to spam it also. But let's create some logs. Okay, so go back to the AWS, go to log groups, and down there you'll see the API gateway, J8M0, which is, yeah, J8M0. Sorry, here. And the state's version 1. You'll see that we have here logs. We have the API key, which is encrypted. We have a method post. It was successful. We have the 200 response, and so on. So we have also the logs of the API gateway. So yeah, this is pretty much it. This is a working API, a working serverless API that it can respond in a timely manner. You do not have the problem of cold start when not after you warm your Lambda. Let's stretch it a bit. For those who do not know what Locust is an open source package for Python to pretty much stress test your application. Here I have written a few lines of code. I have a class which is an HTTP user that allows me with Locust to perform HTTPS requests. I have my headers, I have my payload, and then I perform the post request to predict. So I run Locust, running that command here. It opens the web interface. So let's see. We're going to emulate 500 users with a spawn rate of 100 users per second, and I have my host here. The URL that I just sent you. So let's start. Let's go to the charts. We'll see that we have 200 users, 300. Okay. We have RPS's requests per second. We have almost 130, 150 requests per second. And you see that thing, the cold start. I was consecutively running on one Lambda because I was keep spamming the button. But now that huge burst came, it spawned a bunch of Lambdas. And now the response time goes back to 180 milliseconds, 880, it's always sub-second. We have reached the 500 users, we have 250 requests per second, and everything seems to run smoothly. Do I have any errors? I have 0 errors. We have already did 13,000 requests on the API, and we can monitor this real time. We can go to Lambda, and you can add this thing to a dashboard. on CloudWatch. I have already done that. Just press the button and it creates a dashboard. Already done that. And here you can see that we have 9,000 requests. The duration of the Lambda is dropped from 2.5 seconds to 160, 170. We have 0 throttles because I have the throttling rate to 10,000 requests per second. Okay, that's nice. Everything works. My computer is burning at the moment. Because that actually the 500 users is running on my CPU, and I have a small one.
You can actually make a DDoS attack with Locust, basically.
Yeah. Actually, it worked me. CPU usage above 90%. Oh well.
So at first it took a long time to warm up. That's why it took so long for a response time. But then once it warmed up, then it allows you for way more requests.
Yeah.
And
we already.
Sorry, what counts as a failure?
Traceback on your Lambda, and you get response 500. Actually, anything that is not a success on Locust, anything that's not a success status code, anything on the range of 400 and up, it counts as a fail in Locust. So you can see.
I would guess since the model is a simple model, we won't be seeing any failure, but I would guess if you go to more complex models like deep learning, the chains would be higher up. But what percentage? Is it like is 5% of fail error rate big, or is it good enough for big models?
Well, 100% success rate is good enough, to be honest. If you have built your model correctly, you will not have error messages. This is the error messages is surely depend on the way that you have written your code on your AWS Lambda. Now, if you have a very, very large and heavy model on an AWS Lambda, probably you're going to have timeout errors. Currently, the timeout on Lambda is 15 minutes, but because you are running it on an API gateway,
Les PC aussi 100%, c'est bon, te plante. يب هذاك ايش يا جماعه كي تعمل لوكست طيحه ما تخليش تمشي على طول سينو تبلانتا البيسي نتاعك كيما صاروا تو. Yeah, it would seem like that. We'd have to wait for him to, I think, reboot or something, but I guess, yeah, we're good. Remember, kids, never use 100% of your CPU while streaming something. So I'm going to take a screenshot. Yeah. All right, so Konstantinos has shown us how not to use Locust, and the time it will take him to reboot the computer and come back. If anyone has any question, we want to discuss something by this time, but I think, yeah, that's basically it for the serverless machine learning. And it's actually, there we go.
Yay!
You did that yourself. Again?
Can you hear me?
Yeah, now you can.
Perfect. My internet had a hiccup.
So it was an internet problem. It wasn't a computer problem.
No, it wasn't a computer problem. It handled.
All right, we were joking that you did DDoS yourself.
No, it's fine. Just my internet service here is crap. I'm on my hometown, and it's not very good. We don't have a very good internet.
Good to know that you're not. Good to know that
Yeah.
you're not the only ones with bad internet.
Yeah. So let's go and see what happened here. We crashed it. Like every 1 minute, we had at least 15,000 requests. We hit it with, let me see, how many? How many requests? Oh, I reset it. It was almost above 100,000 requests on the API, and we saw that it was sub-second. Actually, resetting everything. So yeah, this is the API, the serverless API.
Do we have a rundown on how much it costed to run this the demo?
Nothing.
Nothing, because you have perks from AWS, or
No,
nothing?
no, nothing. Because if you go to AWS Lambda pricing, here,
All right, so we have another internet problem, but in the chat, Thanasis
can you
has
hear
shown
me?
us. Yeah, now we can hear.
Yeah, no, I do not have any privileges and all stuff. This is actually when you are in a new account, the free tier. Actually, every month you have 1 million requests for free on the Lambda.
All right.
And
nice.
because I use the simplest solution here is the with 120 megabytes of memory, which is what I'm using currently. You pay per millisecond 0.000000002 cent. So yeah, it's next to nothing. I did 100,000 requests. I did 100,000 requests with 800 milliseconds.
I remember it was an average of 230 milliseconds with a minimum of 80.
Yeah. It's at around 2 cents, 20 cents. Maybe I paid around 20 cents.
Nice. And so we have each month we have free tier, and then you get it's like next to nothing. We have, like, I would guess this would be perfect for pet projects, personal projects, startup projects, whatever that's not that you can put a budget on it right now just to test. This would be perfect for any of these cases, I guess, right?
Yes, exactly. For example, here as an example of pricing, he's using here they're using a half a gigabyte of RAM on Lambda, and they did 3 million seconds, which is a lot. And they paid for the comparison of the Lambda just $18 for the 3 million seconds of running the Lambdas, and they also added 3 million requests on top of that, which is $40. So running a Lambda for 3 million seconds for multiple Lambdas, adding up to 3 million seconds, and performing 3 million requests, you get billed for around $20 per month.
Which again is next to nothing for all the data that you will manage to get, like from testing and reporting, which is next to nothing.
Yeah.
And that's why serverless machine learning is something that everyone should know how to use, I would guess, especially for startups.
Yeah, exactly. So that's it. That's the demo. Thank you guys very much.
So thank you, Konstantinos, for the session, and thank you, Thanasis, too. So we have Thanasis Douglas, who was answering questions since earlier and giving links. So thank you again. If anyone has any last question about Lambda function, the code, the test, links, advice, or anything, We still have a couple of minutes that you can use for that. We still have actually, yeah, we still have 4 to 5 minutes that you can use for the Q&A. So if you have any question, feel free to ask Constantinos. It could be about AWS, it could be about the Orpheum, it could be about the Lambda function, it could be about today's session, or it could be about the machine learning hero experience, or even just his hobbies. So we have 5 minutes left we can use if you do have anything.
Yeah, sure.
So in that case, feel free to just put anything in the comment or raise a hand, and I will give you the right to open the mic. You can do it yourself.
By the way, Thanasis is a colleague of mine. Thank you, Thanas, for answering the questions while I was gone.
I suspected something. All right, so just for the just while I would guess someone has any question, I would just ask one last thing. Would it be possible to have the would it be possible to have some of the screenshots that of the workshop, of the session, locus or whatever, and the boiler code on GitHub or anything that I can send them to the community afterwards so they can test it themselves?
Yes, obviously, yeah. I'll send you a link to my repository where I have already pushed the code there. I'll give you some screenshots, and I'm going to share you the presentation also. Although the presentation doesn't say much, to be honest, it's just theory. But yeah.
That will help maybe if, for example, in the recording, maybe some part of the video is not HD, so we might need the presentation for that. But yeah, I think specifically the screenshots would be awesome of the stress test and some of the names like Locust or Sam. This would be helpful for afterwards. And I think, yeah, I think that's it. That's it. All right, cool. So I see that no one has any question. So I would guess that you managed to relay the information as accurately as possible. I know that people are very shy. I have no idea why, but they start off shy, but then they can shut up. I think we're not there yet. It just means that you were good at relaying the information. So thank you so much for that, Konstantinos. And with this, I would guess that we officially finished the session. I would just stop the recording right now. Let me just